Hello everybody and welcome to Module 4, Lesson 2. Today we're going to be talking about angles. Now we're going to be using, in our I can statement, we're going to be using right angles to determine whether angles are equal to, greater than, or less than right angles. And that's going to help us define the three major types of angles. Today we're going to also be learning how to draw these angles, and I'm going to help you define those in just a few minutes. Now, the first thing that we need to do is we need to create a right angle tool. So I need for you, if you don't have a piece of paper, to pause this video right where it is, and I need you to go get a piece of paper. Now, my piece of paper is going to be just a piece of construction paper, and yes, you can see that my iPad or iPhone projector is set up on some Clorox wipes. So that's very fitting right now for COVID-19. I don't have a projector to put this on, so here we go. I'm going to do it this way. So go get a piece of paper if you don't have it and come back and unpause the video. All right, now that you have your piece of paper, I just have a piece of construction paper. And what I'm going to do with my construction paper is I'm going to fold it just like they would say in art class, hamburger style. So I'm going to do this, and I need to be really careful. I don't want to fold it sloppy because that is going to make my right angle tool not a right angle tool. So I want to make sure that this is perfect. So I'm going to fold it once, matching those two ends, increasing it really good at the bottom. And then once I have done that, I'm going to fold it again. Just like this. So I've got now my paper folded into fourths. Now right here in this corner, and really in any of these corners, it doesn't matter, I have a perfect right angle. And I'm going to label this right angle with the mark that we use when we actually measure or when we show that an angle in a picture is a right angle. And what we do is we just draw a small square just like this in the corner. I'd like for you to do that too, to your right angle tool. And I'm going to actually write right angle. And we haven't talked about how to measure angles yet. That's coming. But a right angle measures exactly 90 degrees. And this doesn't mean the degree is like how hot or cold it is outside, but this is how we use our units of measurement when we're talking about angles. So you'll be learning a lot about this week, but this is a right angle and it is exactly 90 degrees. Now some angles are greater than 90 degrees, some are less, and some are exactly equal to 90 degrees. But what you need to know right now is that a right angle is exactly 90 degrees. Now in your book, we've got some pictures of different angles. So let's open up. This is your Learn book, and I'm on page 13, and it says Lesson 2 Template. And what we're going to do is we're going to actually measure some of these angles, and we're going to see which ones of them are equal to, greater than, or less than a right angle. So the important thing is I'm going to take the corner where I've marked this square, and that's indicating that this is exactly a right angle. And I'm going to take this corner and I'm going to match it up with the vertex of each one of these angles. Remember, the vertex is the common point where the two rays or line segments that make the angle meet. So I want you to do this along with me. I want you to take your right angle template and I want you just to put it right in the vertex of angle A. Now, take a close look at this. When I look at this angle, I can see that both rays of the angle are lining up perfectly with my right angle template. And that tells me that angle A is equal to a right angle. And because this is a right angle, I'm going to change this little mark inside. This little mark is in every one of these angles. Do you see that? And that just shows me that they're pointing out an angle. But because I know that this one's a right angle, I'm going to change this now to that little square. So I know that angle A is equal to a right angle. All right, let's try angle B. Remember, I'm going to take the corner, my right angle, and put it right in the vertex of angle B. All right, I'm going to make sure that I line up one straight side of my right angle with one of the rays of angle B. Now I could do it this way if I wanted to. You can see the ray over here. Or I could do it this way if I wanted to. As long as I have my right angle's vertex lined up with angle B's vertex and one of the sides matches my right angle template. Now, it's kind of funny here because I can't seem to see both of the rays. Can you? What this is telling me is that angle B is less than a right angle. It's smaller. I can see it hiding under there. So angle B is less than a right angle. They're not really that different looking, are they? But this one's just slightly smaller, just slightly less than a right angle. Okay, I'm going to do another one now. This one is angle C. So once again, I'm going to match up the two vertices is how you would actually say it. I don't want to say the two vertexes because that's not how you say it. But I'm going to put the vertex of my right angle template with the vertex of my angle. Remember that what I want to do is I want to make sure that one of my rays matches up with my right angle template. And I can either match up the vertex and this ray, or I can match up the vertex and this ray. It really doesn't matter. Now, what do you notice? Is it equal? Definitely not. This angle C is not equal to my right angle because it actually is a little bit bigger. It's greater than a right angle. And I know that because I can see this ray kind of going off to the side. So I know that angle C is greater than a right angle. Now you can probably begin to look at some of these angles on your paper and you can probably begin to guess which ones might be actually equal to right angles. Do you have any idea which ones might be equal to right angles? Well, if you said E, you're probably right, but we're going to check it just to be sure. Let's match up the vertices, line up one ray. Wow, both of these rays line up. So this one is equal to a right angle. You can probably also see that G looks a lot like a right angle too, and I almost forgot to put that right angle sign in. Let's check and let's test G. So I'm going to match up the vertices, match up one ray, and in this case both rays match. So this one is equal to a right angle as well. Once again, I'm going to put that square inside. I'm only going to do that for the angles that are equal to a right angle. J looks a lot like a right angle, and if I wasn't being really specific, I might guess that J was a right angle, but let's check just to be on the safe side. Let's take the vertex of our right angle template, match it with the vertex of angle J, line up one of our rays with our right angle template, and boy, I can see right now that angle J is greater than a right angle. Do you see any other angles that seem to be greater than right angles? If you said I, you are definitely correct. Angle I is certainly greater. Look at that great big circle there. That definitely greater than a right angle. That's a dead giveaway. In fact, it's almost a straight line, but not quite. And if you said angle H, you were also correct, but we're just going to test it to make sure. I want you to always do that. I'm going to match up the vertices, match up the side of my right angle template with one of the rays, and definitely, yes, H is greater. And the last two angles, well, they really kind of look to me like they are less than a right angle, but I just want to double check. So once again, I'm going to match up the vertices of the right angle template and the angle I'm measuring, match up one side of my right angle template with one of the rays, and look at that. The other ray is definitely hidden. So this one is less. And F looks less, but just, again, I'm always going to make sure that I check. Geometry is very specific. Match up the vertices, line up one of the rays, and yeah, the other one is hiding, barely hiding. So it is also less. All right. Now, these angles have specific names. And so this is something I want you to know. It's on your vocabulary sheet for today. But these three different angles have different names. We can't just go around saying, hey, that's a less than 90-degree angle, or that's an equal to right angle, or that's a greater than right angle. These angles have names, and I'd like to show them to you. A right angle is equal to 90 degrees. That's easy to remember. An acute angle is less than 90 degrees, and here's how I remember it. You see that word cute? Everybody thinks about little kids being cute, right? Or little babies being cute. So an acute angle is a little angle. It's less than 90 degrees. It's less than a right angle. So all of these angles that are less than 90 degrees have a name, and that name is acute. So let's go back to your angle template and let's name the less than 90-degree angles acute. This one is acute. This one is acute. Now I know that my equal to a right angles, these are actually just called right angles. They stand up straight, they're right. They're like the good kid in class. What about those greater than right angles? What's their name? Well, it's on your vocabulary sheet, and it's also right here. They are called obtuse. Now that word obtuse has different meanings in the English language. Sometimes it means not very smart or sort of thick in the head. But right now we're going to think of obtuse being very big. It just kind of has a big sound. So when I have an angle that is greater than a right angle, but less than a straight angle, and we'll get to that. We'll talk about that definition a little more in detail. But when I've got an angle that is greater than a right angle, but it's not laying flat, then I call it an obtuse angle. So I'm going to come back and I'm going to label my greater than angles obtuse. You can do that with me. So I can think of acute as that little angle and a right angle as perfectly square in the corner, and obtuse as a greater than right angle, but not lying straight. You might be thinking, well, what do we call an angle that is straight? Let me get out my straight edge. And I'm going to draw a straight line. And I'm going to put a vertex because this is the meeting of two rays. This is actually called a straight angle. Pretty easy to remember. And we'll talk about what its measurement is in degrees later on. It's actually 180 degrees, because some of you like to know this stuff. So I'm not going to hide it from you. So we've got right angles equal to 90 degrees, acute angles, which are less than 90 degrees, obtuse angles, which are greater than 90, but once they go to laying down straight, they are called a straight angle. So that's the terminology that we need to know today. So how do we draw these angles? Well, on your paper, let's practice drawing the 3 types of angles that we learned today. Let's draw a right angle. It is by far the easiest one to draw because you're going to use your template. In fact, you're going to use your template for all of these today. So we're going to draw a few right angles. The first one I'm going to do, just going to be really easy. I'm just going to trace right around that corner, that right angle. I'm going to give my right angle a vertex, and I'm going to show the 2 rays. And of course, I'm always going to label it with that little square inside. Now, what if I wanted to draw it like this? Would it still be a right angle? Absolutely, because the corner still equals exactly a right angle. That vertex or that corner equals a right angle. So it doesn't matter. Lily is still Lily when she does gymnastics and flips upside down, right? So right angle, when it does gymnastics, is still a right angle. I'll draw one more. Still a right angle. Lily's still Lily. Alrighty, I've got 3 right angles. There we go. These are my right angles. I want you to draw some right angles too. You can stop me anytime you want. I know I'm going fast. I'm only doing that because it takes about 1,000,000 years to upload these videos while my kids are watching TV, using my data. So we're going to make this easy. All right, let's draw some acute little angles. I'm going to draw an acute. I'm going to think that this is acute. It's got to be less than my right angle. So I'm going to draw my first acute angle. I'm going to just take my right angle template and I'm going to trace along just one side this time. Now, in order to make my my acute angle smaller than my right angle, that means I have to draw the other ray of this angle somewhere underneath this paper. So I think if I make it like this, that would probably be acute. So I'm going to draw another ray and another arrow. And I'm going to check it and see, oh yes, that other ray is hiding. So it's acute. Let's draw one more. Acute. And again, it doesn't matter which way I draw it. You can flip up in the air like a gymnastics person. Let me draw one ray and a vertex. This time I think I'll make it a little bit bigger. I think I'll maybe make it look like this. I'm going to give my rays arrows. And I'm going to show my vertex, show that's an angle I'm drawing. And just because this is geometry, guys, we got to be specific. Let's test it and see. I'm going to match up my vertices, match up my ray. And if my other ray is hiding, then yes, cha-ching, I have drawn an acute angle. Look at those. All right, I want you to draw a couple of acute angles too, please. And now we're going to move on. I bet you can't guess. We're going to draw some obtuse. Thinking big. Obtuse angles. Now remember, obtuse angles aren't laying down flat. Those are straight angles. So my obtuse angles have to be greater than my right angle, but they cannot lay flat. All right? They're still doing a little bit of a sit-up. So I'm going to use my right angle template again. Just like making my acute angle, I'm going to trace one ray along one side of my template, and I'm going to give it an arrow. And this time, because it's obtuse, that means my rays cannot be hiding underneath my right angle template. So I got to make it bigger. So I'm going to line up those vertices, line up that corner with my point here, and I'm going to draw another ray. I can look at that and I can say, you know what, that is definitely an obtuse angle. I'm going to